In this video, I'll be demonstrating DroneReqValidator, an sUAV test simulation ecosystem. First, we need to address the problem that we're trying to solve. Then, we'll give you a structure overview of the entire ecosystem, and then we'll give you a live demo of the entire application. So the problem that we're trying to solve is that we need a sUAV test simulation that is realistic and easy to configure. And to solve this problem, we present Drone World, a test simulation ecosystem that uses Unreal Engine and AirSim. And here is the structure of the entire workflow. So first, a user will have a set of simulation need, and then he will use the React frontend to configure a mission and test property. And then the frontend will send that configuration as a JSON to the Python backend, and then the backend will let the mission dispatch system, which uses AirSim API to run the simulation, and then generate a mission and test property monitor, and then uses that to start the Unreal Engine simulation. Once the simulation starts, it will dispatch the mission and then start the user-defined environment and mission, and while continuously monitoring the mission and return the camera stream back to the user. And once the simulation is done, the middleware will collect the simulation report and then present to the user using the front end. Then the user will see the test results and then modify or improve their script and then start a simulation again. Now allow me to give you a demo. Here is the front end page. From here, the first page, we will select a requirement ID. And so for the first one, it says that a two sUAV will be able to complete the circular path and a square path in a windy weather without colliding with any objects, and it should not drift from its planned path by more than 10 meters. So we will try to configure a mission that satisfies this requirement. So first, in the first page, we'll configure an environment. So here, it says in a windy condition. So that means we need to have some high wind here. So let's say 7 meters per second of wind. And here is the fuzzy test enabler. When we enable this, this will simulate multiple scenarios using different wind velocities. But we're not using this for this time. And then we can specify a region. So here is the predefined region that is the Chicago airport. But we can use this page to select any place on the map that we want. But for simplicity, we just use the airport. So we can select here. And here we can also select the time of day, which affects the brightness of the environment. Okay, so next page, we'll configure the mission, which is the drones. Here, the requirement says that we need two sUAVs. One is a circular and one is a square. So we will add another drone here. And in the first one, we'll give it a name of the default name drone 1, and then give it a square mission. And here is the spawning location of this drone. And the next one, we'll give it a circular path and increase the latitude by a certain degree, by 2 meters. And we can also specify each parameters, each sensor properties here, but we are not going to use that for this run. The next page, we'll configure the test properties. So in this page, in the requirement, it says without colliding with any stationary object. So we will toggle the collision monitor on. And then it says it should not drift from its planned path by 10 meters. So that we'll just configure this and set this to 10 meters. So after this is done, we'll click finish. And now the simulation will start. So now in the simulation, we can see that first drone is using the circular square path. And we can further inspect each drone here. So the first drone, as you can see, is flying in square. And the next drone is flying a circular path. And once they are finished, we'll have a report generated for us. So here is the report that it generated. So from the report, we can see that there's no collision between each drones. And then for the drift tests, the first drone drift with less than 10 meters, and here's the path graph. and the second drone drift less than 10 meters, and here's the drift graph. And we can further zoom in. As you can see, there's no the planned path is the blue one, and the actual path is the orange one.